Have you ever wondered how your favorite apps and websites just work? Behind almost every single piece of digital magic, there's this unsung hero, a silent organizer that keeps everything from falling into chaos. So in this explainer, we're going to pull back the curtain on that powerhouse, the Database Management System, or as you'll hear it called, the DBMS. To really get why this stuff matters, let's start with a classic problem. Picture this. It's the concert of the year. There is exactly one ticket left, and two different people hit buy at the exact same millisecond. So, who gets it? Who sees that amazing confirmation screen? And who gets that dreaded, sorry, sold out message? This isn't just a coin flip, It's a really deep challenge of managing data that's shared and, in this case, extremely limited.
Now, what's really interesting is how you could try to solve this. You could have two separate systems, right? Maybe one for online sales, one for the box office. But can you imagine the chaos? You'd be double selling tickets left and right. You'd have no single source of truth. It would be a complete nightmare. The only sane way to do it is with a single central database, where every single sale is recorded instantly.
And that idea right there, it leads us straight to the core issue these systems were built to solve in the first place. Let's call it the data chaos problem. Because without a good manager, data just gets messy, unreliable, and honestly, pretty dangerous.
Think about it like a group project on a shared document. If everyone just downloaded their own copy, made a bunch of changes, and then tried to smash them all back together at the end, disaster, right? Sentences would get overwritten, whole paragraphs would vanish. It'd be awful. The goal, the absolute dream, is to have a system where everyone can be in that same document all at the same time, and somehow, miraculously, nothing breaks.
And that dream, well, it's made possible by the hero of our story today. So it's time to formally introduce the solution, the DBMS.
So what is a DBMS really? At its heart, a database management system is this super specialized software that's designed to be the ultimate gatekeeper for your data. It's the tool that lets you store, edit, organize, and, this is key, secure all of your important information in one central, totally reliable place. It's like the librarian, the security guard, and the obsessive-compulsive organizer all rolled into one. And believe me, it juggles a lot of jobs to make all that happen. First, it stores data centrally, which, avoids that whole duplication mess we talked about. It allows tons of people to share and use that data at the exact same time. It gives us user interfaces so we can actually work with the information. And crucially, it controls who gets to see what. It creates backups just in case of a disaster. And it makes sure the data is always consistent and trustworthy. Now, that point about controlling access, that is one of the most powerful things a DBMS can do. So let's really dig into that next. Let's talk about how a DBMS controls the flow of data. So a DBMS does this using a really clever idea called views. You can think of them as different windows that look into the exact same room of data. At the very top, you have the external view. This is what you, the user, see, like a simple form on a website or your profile page. Underneath that, there's the conceptual view, which shows the designers how all the data tables are logically connected. And then way down at the bottom is the super complex internal view, which tells the computer exactly how and where the data is physically stored. And here's a perfect example that makes this crystal clear. Think about your bank. A teller logs into their system and their view shows them your account balance. Simple, right? But a programmer working on that same system has a totally different view. They see the complex code, the file structures, all the nerdy details. It is the exact same database, but they get completely different views based on what their job is. And this same idea is everywhere. Take a music service. As a customer, your access level lets you see your personal music library. But an administrator, they can see and edit the entire music catalog for everybody. And maybe an account manager has a special view that just shows them the financial data. The point is, a DBMS customizes what you see to keep data secure and, relevant to what you actually need to do. Now, this all sounds pretty great in theory, but what happens when this intricate system of data management goes wrong? Well, the consequences can be, let's just say, catastrophic. Let's take a look at what happens when these data systems fail. This quote right here just perfectly captures a real-world disaster. When the company Target expanded into Canada, they ran into a huge data problem, which led to this exact situation. Empty shelves in their stores, while tons of products were just sitting in warehouses, completely invisible to their system. So what happened? Well, the core problem was just bad inventory data. The information they had was full of wrong product dimensions, duplicate codes for the same item, you name it. And the result was that the digital records in their database didn't match the physical reality in the stores. Supply chains completely broke down, customers got super frustrated, and this data failure was a major reason why the business ultimately had to pull out of Canada.
It's a pretty sobering story, right? And it brings up a really critical question. With so much at stake, how do you stop that kind of disaster from ever happening? How do you guarantee your data stays trustworthy? The answer lies in a set of 4, let's call them sacred rules, that govern every single transaction in a reliable database. They're known by the acronym ACID. First up is atomicity. It's all or nothing. A transaction either fully completes or it's like it never happened at all. Next is consistency. A change can't break any of the database's fundamental rules. Then isolation. Lots of transactions can happen at once, but they can't step on each other's toes. And finally, durability. Once a change is saved, it's saved forever, even if the power goes out a second later. These 4 rules are the bedrock of reliable data. Okay, so we've talked about the problems, the solution, and the rules that keep everything safe. This brings us to our last and maybe most important section. Why do these DBMS skills actually matter to you?
Look, understanding how databases work isn't just some abstract, technical thing. It opens up real-world doors. It's essential for jobs at banks and cool tech startups. It's totally fundamental for degrees in computer science and cybersecurity. It's the backbone of being a data analyst. And honestly, it's what you need to know if you ever want to build your own app that people can actually trust with their data.
So I'll leave you with this final thought to chew on. Now that you know the basics, imagine you had to design the database for your school's club signups. What kind of views, what kind of access levels, what kind of rules would you put in place to make sure everything was secure, reliable, and didn't end up in total chaos? Something to think about.